Hey guys, this is Miss Morrison. Some of you requested a little help on your graphing, so I realized I went pretty hard and fast, and if we haven't graphed in a while, we probably forgot, and we might be having a little trouble with the numbers and the points. If you are already good at drawing points and domain and range and all that hoopla we covered in class, then just hang up this video and I'll see you on Wednesday. Monday we don't have class, it's Labor Day. But for the rest of you, if you want to watch this video, go for it. Alright, so first we're just going to draw points. And if you already know how to do this, you can fast forward it. And yeah, so let's remember that X is this side-to-side axis and Y is this up and down axis. And if you want to, there should be a blank copy of this on your blackboard. And I think I attached it to the announcements. Anyway, okay, so all of these suckers are XY, 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 XY. Okay. And anything in this top right quadrant, we go through 1, 2, 3, 4, 5, 6. So these X's are positive. So all the ordered pairs in this top right quadrant that look like XY, they all look like XY, but the X values will be positive in this top right quadrant. Quadrant means 4 pieces. Yep, quad means 4. So quadrant means there's 4 pieces to this graph, and we're looking at one of the 4. Okay, anyway, so the X's are positive, and then let's see what the Y's are. Well, when we go up, we count with positive numbers. So the Y values are positive over here. On this left side, when I make an ordered pair of XY, let's see. My X's over here are not positive. When we go left, they go negative. So the X's are negative in this area, but then the Y's are still positive. So in this top left quadrant, the X's are negative, and the Y's are positive, plus, positive. Okay, let's move on to another quadrant. Let's look down here. And if you know this, but you still want to review, just fast forward. Alright, so over here, in this bottom left, what surrounds it? Well, the negative X's surround it. And then the Y's, when I count down, those are negatives also. So this ordered pair is negative, negative. Looks suspicious. Okay, and then over here on the right, the X values are, let's see, let's cover this quadrant. The X values are, don't look at my fingers, positive, and then my Y's are negative. Okay. Okay, so now let's draw our points. It might have been a while. Okay, so let's do this 3, 5. That means I need to go to 3 on the X. So we start at the middle and we go 3 on the X. Don't draw the arrow. And then 5 means we go up 5. So 1, 2, 3, 4, 5. So we went to the right 3 and up 5. And then where we land is the actual point of 3, 5. So 3, 5 is not these arrow thingies. I was just showing you how to get there. This big dot is 3, 5. Okay, let's look at this negative 4, 8. Well, negative 4 is in the X. The X goes side to side where the negative's at. If you don't remember, look up here. Anything that's negative, comma, positive, like our negative 4 and our pretend positive 8, that's in this top left. So let's go negative 4 on the X. X is side to side. Negatives are on the left. So I'm going to go left 4. I think I end up like right there. Then I'm going to go up 8. Up 8. let's see, 1, 2, 3, 4, 5, 6, 7. Oh no. Okay, I went off. So, negative 4, 8 is not right here. Negative 4, 8 is up here after you've already done your X and your Y. And my dot went off the graph because I didn't think about it before I made this. Okay, let's keep going. Another. Let's look at this 2, negative 6. Well, if we can't quite remember where that belongs, it's a plusative, comma, a negative, so it's got to end up somewhere over here in the bottom right. Okay, so let's go to 2 on the X. There's 2 on the X. Then we're going to go negative 6 on the Y. Well, here's the Y, and the negatives go down. So let's go down. 1, 2, 3, 4, 5, 6. Yeah, okay. So this new point represents 2, negative 6. And here were the other points. Okay, let's do this bottom left. It says we still have to do this negative 5, 3. Or negative 5, negative 3. So that they're double negative, so negative 5 means we're going to go negative 5 on the x-axis. I think that's negative 5. That's 5 tick marks to the left, or negative. Then we need negative 3, so we got to go down 3 tick marks. 1, 2, 3. Okay. And our answer is this dot that is 1, 2, 3, 4, 5, 6 ticks to the left. Oh, I went too far. Crap, let me try that again. Poop. Okay, I'm supposed to go negative 5, so help me out. 1, 2, 3, 4, 5. I went too far. Dagnabbit. Okay, so I went left 5. Can't count. Okay, and then I go down 3. And my new point is right here. I did it wrong. Of course. Okay. So yeah, that's a little help if you needed how exactly to put the dot where it's supposed to go. And you don't always have to go, for example, right 3, then up 5. I could have seen that I have a y of 5 and gone up 5. And then right 3. If that confused you, forget it. Okay. Erase it from your memory. Okay. Let's look at this next sucker. We have to draw the points and then do the domain and range. Well, let's remember. Top right, plus plus. Top left, negative plus. Bottom left, negative negative. Bottom right, plus negative. And this is going to help so much, even when you go to pre-cal, because when we get to calculus, even though the math will be horrifying, this plus, negative, that'll all be the same thing. Okay, so let's graph this 3, 2. Okay, that's 3 on the x. On this picture, my x had to be on the left because I ran out of room. Okay, so I'm going to go 3 on the x. Where is 3 at? Well, 0's in the middle. To the right is 1, 2, 3. Okay, so I go 3 on the x. Then I have to go up 2 because it says 2 is a y. So 2 is the second tick mark up. So I go to the right 3, up 2. Hey, 3, 2. Okay, let's do another one. Negative 1, 6. Well, x is negative 1, so go left 1, because remember the negatives are on the left. And then the y value is plusative 6. Well, the plusatives are up top, so let me find where 6 is going to land. And you don't have to draw these little numbers. It's just I messed up on the last problem, so I don't want to do that again. So I went left 1, up 6. Shaboozy. There it is. Negative 1, 6. Let me go ahead and label these with x's and y's. Okay, so we've done that one, that one. Now let's look at this 4, negative 2. That's x and y. So let's find 4 on the x. Okay, don't go left. I know I put that letter x on a weird spot, but quit freaking out. Okay, we go to 4 on the x. Well, here's 3, here's 4. Okay. And then I go negative 2. That means negative 2 on the y, because negative 2 is underneath, or on top of the letter y. So the negatives go down. Negative 1, negative 2. Okay, so I went 4 to the right, down 2. Bam. And that's 4, negative 2. Lastly, let's have negative 5, negative 3. They're both negatives. So that's in this bottom left. So negative 5 is left. 1, 2, 3, 4, 5. That's negative 5. Okay. Then I'm going to go negative 3 on the y. Well, negatives go down. So 1, 2. Here's negative 3. And we put the dot where they meet. Yeah. So that's another way you can try and plot your point. Instead of thinking left 5, down 3, you can say, hey, here's negative 5. Hey, here's negative 3. Where do they meet? Shabam. Okay. Let's do our domain and range. Domain is x's. Okay. And these are not connected. These dots are not connected. How do you know? Because they weren't when they were drawn. They weren't already drawn for you. So the only time things will be connected is when it's already drawn for you, or we can see it on our calculator, but we haven't even touched our calculator. So these are not connected, so we got to use squiggle, squiggle. Yeah. And we're going to list our x's. So a 3, 4, negative 1. Oops, and I forgot to label this one. And negative 5. But we have to write the smallest to the biggest. Well, I know the biggest x value is this 4. And right underneath it is this 3. And then we keep going. So your smallest x value is your most negativist x value. So that means the biggest negative. So negative 5 is actually our smallest number. And then negative 1, and then 3, 4. Okay, now let's look at range. Range is y's. We're still going to start with the squiggle. Okay, our y's are negative 3, a negative 2, a 6, and a 2. But we have to do them smallest to biggest, or bottoms up, bottoms up. So the bottomest y value is not this negative 2, because this other guy was even lower. So negative 3 first, comma, the negative 2. Keep going. Bottoms up. So that was bottom. That was a little bit higher. A little bit higher than that is this point with a y value of 2. A little bit higher than that is the very tip top point with a y value of 6. And all these numbers are supposed to be in the squiggle, but I ran out of room. Okay, lastly, it says, is it a function? Well, that only happens if the x's repeat. If the x's do not repeat. So remember, we can only function in our life if that annoying x of ours stays away from us, okay? So, sorry, an email just popped up and I got distracted. So anyway, if the x's repeat, it's not a function, because if that x's come back into our life, we can't function, we get stressed. Okay, so let's look at our x's. I got 3, negative 1, 4, negative 5. Yeah. Are any of those repetitive? Nope. So that means, yes, it's a function because the x's did not repeat. It's like saying, I can function in my life because all those ex-boyfriend, well, whatever, ex-whoever is gone and they're staying out of our life. Okay, another one. Let's look at this little Stewie. Okay, it says domain and range. Okay, well, this is where we have to count where our points are. So in this bottom left quadrant, everything is negative, negative. So every single number for these points are going to be negative. Okay, let's see what they are. For domain, you have to do the x's, which is the leftist, comma, the rightist. And these are connected. Okay, and let's remember that closed holes use bracket and open holes use parentheses. Okay, so for my x's, my very left is part of the graph, comma, the very rightist part of the graph. Let's see what it is. The leftist piece of the graph is this dot on the very left. Let's see where that's at. It's at left 1, 2, 3, 4, 5. And remember, we write the x value first, then the y value. So this dot happens at an x value of -5 because it came from the x-axis. And then the y value, how much we have to go down, is -3. So this dot right here is at -5, comma, -3. And that's x and y. Let's look at the rightmost part of the graph. It's this little dot right here. It's kind of janky, just close your eye, pretend, okay? And let's see what his ordered pair is. Let's see here. We're going to start at the middle, and we have to go left -1, and then we have to go down 1, 2, 3, another -3. Okay, so domain, when stuff is connected, is just the left and the right. That's why I only labeled the left dot and the right dot. That middle junk is going to be taken care of by the comma. Okay, so let's look at our x's. I have a -5 and a -1. Which one's the smallest, or the leftist, or the most negativist? Yeah, -5. Okay, out of these two x's, which one is the biggest, or the not a bigger negative? And it's the -1. Okay, both of these dots were closed, so I need to use a hard bracket around them. Okay, there's my domain. Let's look at my range. Range is the y's, and for range we have to have bottoms up, bottoms up. Yeah, drink that sweet tea up. Okay, so let's look at our very bottomest piece of the circle. Hey, it's this dot. Okay, let's count how to get there. Well, I have to go from the middle. 1, 2, 3, -3. Okay, and then it looks like I have to go down 1, 2, 3, 4, 5, -5. Did I count that right? Yep, and that's x and y. All right, and if you notice, it's the same kind of numbers as this very left-hand point. It's okay. Don't have a panic attack. Okay, now let's do this top point. Okay, we're going to go left 3 for sure, but then we just go down 1, -1. This is super awkward. I have no idea how it turned out this way because I just randomly drew. Okay, so the numbers are a lot like these blue ones, but it's okay. It's okay. We're going to ignore the blue ones. Just look at the orange. Okay, range is the y's, the bottomest, comma, the toppest. My y values are -1, that's the toppest. The bottomest is -5. Yes, I know there's some points in between, but we just want the lowest y value, -5, because it's that at the bottomest. And I just want the toppest y value from this point, and the toppest y value is that -1. Both of those numbers came from closed dots, so use brackets. Okay, x-intercepts. That means where we touch the x-axis. Well, this little circle did not touch the x-axis, and it did not touch the y-axis. So there are no x or y intercepts. Okay. Function means, hey, can I draw that up and down line? And, you know, if I hit twice, it's no bueno, because my x's repeat and I don't want them in my life. Okay. So if I draw an up and down line, say right here, this line touches the circle once, twice, and that's no bueno, especially because if you look at the actual numbers, those x's of -3 were written twice. So this is not a function because the x of -3, we saw it twice. And it's also not a function because an up and down line touched my curve twice. So we could have either looked at the numbers and saw the -3's happen twice, or we could have drawn an up and down line and saw that we touched the curve twice. Okay, now let's look at this parentheses hoopla. Okay, the stuff inside the parentheses is the x. And they want the y. Okay, well, let's see here. Let's find when the x value is -3. Here's an x value of -1. Oh, look, the -3's, they're already written out for you. Okay, so it says f parentheses -3 equals blank. It's asking for the y value because this is like saying f of x equals y. I think on our notes, usually I would write it above this black f parentheses blah, 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 yeah, okay. Yeah. So anyway, when our x's are -3, I have two y values, -1 and -5. Write it down with a comma, no parentheses, no. And it does not have to be smallest to biggest. Okay, let's look for when x is -1. Oh, hey, here it is. Okay, what's the y value? Well, 3. And that's the only point that has an x value of -1. So that only has one answer. Let's look at f of 6. That means 6 is x. Where is 6 at on the x? Over here. Okay. Well, do I have a dot over here? Nah, my graph is way over here. So f of 6 actually does not exist. Nope. Yeah. Because way over here, my picture isn't even over here. So I can't find a point. Okay, from the picture. Now it says for what x is f of x equals -1. So this is saying x equals what, because what is like a who, what, where, when, how, whatever. It's a question mark. Okay, and then this says f parentheses x equals -1. Well, remember, when we see f parentheses x, it's equal to a y value. So this -1 is what our y is, when y is -1. So let's find when y is -1. Okay, it's a bad picture, but let's just pretend that the only spot is right here. When y is -1, what is the x? -3. Hey, gracias. Okay. Let's do another one. Uh-oh. Okay, first, we only carry about the left and the right, the bottom and the top for domain and range. So the leftist is this double arrow. And remember, in this top left quadrant, everything is negative, positive. That's the very leftist spot. The very rightmost spot, it's this hole right here. Let's see where this is at. 1, 2, 3, 4. Then we have to drop down 1, 2, 3, 4, 5, 6, 4, negative 6. Okay. Let's do our domain. X's. It's left to right. As in the X value from the very leftist part of the picture. So the X value from the very leftist part of the picture is negative infinity. The X value from the very rightmost part of the picture is 4. Okay, let's remember that open holes and arrows use parentheses. Let's remember that closed holes use brackets. Okay, so negative infinity came from an arrow, so we're going to surround it with this thing. Okay, then that 4 came from another open hole. So open means we're going to surround it, we're going to hug it with that parentheses. Okay, now let's do our range. Our range is the bottomest piece of the graph, which is down here, 4, negative 6, and the tip-toppest. The highest piece of the graph are not these humps. It's the arrow. So technically, our lowest and highest, or our bottomest and our uppest, is already labeled. Okay, so let's find the y value from the bottomest portion of this picture. Here's the bottomest portion. The y value is negative 6. Okay, the tip-toppest portion, the y value is not this dot, it's higher, infinity. Both of those need parentheses. The negative 6 came from the open hole, so we need to surround ourselves with a hug of a parentheses. The infinity came from an arrow, and arrows mean parentheses, so I need to surround myself with a hug of a parentheses. Okay, let's keep going. X-intercepts, that's where we touch the x-axis. My x-axis is this side to side, and I'm touching right here. Let's see how far we had to go over. 3. Okay, and let's remember that 0 is right in the middle. Okay, so my XY point is 3 was on the letter X axis, so 3. And then Y, I didn't go up or down. So my Y value is not 1, 2, 3, no. My Y value is just 0 at this dot because it did not go up or down. All right, so my x-intercept, we can say 3, 0 or 3. And for x and y intercepts, we always use parentheses if that's the way your homework wants them. Okay, let's look at your y-intercept. It's the dot from your curve that touches the y-axis. The y-axis is this up and down line. My curve touches that line right here. Okay, his xy, let's see, what is this 3 on? This 3 is on the y line, so I'm going to put a 3 in the y area. Okay, my x is just 0 because the dot is not to the left or to the right. We just go straight up. So that's my y-intercept, 3 or 0, 3. And I did not mean for it to be all 3's. It just came out that way. Okay, let's look at f parentheses negative 1. Remember, this is like saying f parentheses x equals y. So I need to know if my x is negative 1, what's the y? Well, let's find negative 1 on x. That's to the left. Okay, well, when I go to the left, I'm not on the curve. So you either rise up or fall down. I think I'm going to rise up. Hey. And I have to rise up 1. So this little point is, we went an x value of -1, because remember we went left 1. Then the y value, you have to go up 1. So the y value is 1. Okay, so let's translate it into this f hoopla. F parentheses -1, that's the x value. So the y value is 1. Okay, let's go again. F parentheses -2. Okay, so that means go to -2 on the x-axis. Okay, and then either rise up or fall down. And I rise up. How much do I rise up? 3. Okay, so this point has an x value of -2, because we went left 2. But then we rose up 3. Rosa. Okay, so f parentheses -2, -2 is the x, and we're equal to 3, because that's the y. Alright, let's see what this one says. This one says, for what x, okay? That means x equals question mark, because what is like a who, what, where, when, why, question mark kind of thing. So x is question mark when f of x is equal to 5. Well, let's remember that f of x is also equal to y. So it's saying, what is your x when you got a y of 5? Well, let's look. They gave us a y of 5, so we got to go at 5 on the y, not the side to side, the up and down. So let's go up to that 5, 3, 4, 5. Here's 5. Okay. And it's asking, what is the x? Well, I'm not on a curve, so I need to either go left or right. So we just did the y, which is the up and down. We went up 5. We took care of the up and the down. Now we either have to go left or right. So I think I have to go left all the way over here. So this point should be 1, 2, 3, 4, 5, 6. Okay, whew, golly, that took me a while. Alright, so this point up here, remember we write it as x comma y. Well, what number is in the x? Not this 5. It's the -6. Because we went 5 high on the y. Okay, so the question was, what's your x value when your y is 5? Well, we just figured it out. When our y is 5, our x is -6. Yay! Okay. I think I'm going to do this one with you, and then after that, I'm just going to put the answer key on Blackboard in case you want to look at the rest of these. But I think we've done the hardest one, and this one just looks weird. Alright, so let's look at this guy. It looks like a little slippery snake. Yeah. When you get to pre-cal, this is actually like the equation of y equals sine x, like SOHCAHTOA kind of thing. Yeah. What? But for the rest of us, let's just check it. Let's just check it, okay? Let's see what's going on. It looks like this is kind of like a wavelength that's just fluctuating. It's going up and down to the same spot. Up to the same spot, down to the same spot. Up to the same spot, down to the same spot. Up to the same spot, down to the same spot. Up to the same spot, down to the same spot. Okay, so this is a trick. Because let's look at what the highest y value is. The highest y value is a number 1. Okay? What's the lowest value? Lowest y value. That's a -1. Okay? What am I describing when I'm talking about the y's? Which one of these? Domain or range? the range. So the range is the y's. And we remember when everything's connected, we say bottoms up, bottoms up. Okay, the bottomest y value is a -1 because all of these bottoms of these humps, they all have a y value of -1. And even if I keep drawing this picture, it's going to have a y value of -1. Okay, the tip-top y value is +1. Okay, if we remember back to our tricks, it said something about closed holes are brackets. And then it said something about open and arrows are parentheses. Well, when it was talking about the bracket, it also mentioned something about a solid piece. Yeah, okay. Well, even though these curves don't have any fat dots on them, these curves are made up of thousands, bagillions, trillions. I don't even know what words I'm saying. This curve is made up of a thousand bagillion little closed dots, all next to each other, connected, and that's why we get a curve, because a bunch of closed dots are connected to each other. They're right next to each other. So anyway, the point is, since there ain't no open holes on this one, since it's a solid curve, it's technically a closed dot. And I use a bracket around that one. This -1, well, technically at the bottom of this curve, it's a solid dot, because solid pieces have solid dots all up in them. So our bottomest y value actually has a bracket also. So that was kind of tricky. If you have a curve and you're trying to look, if there's not an open hole on it, if there's not an arrow, then it's made up of thousands of bagillions of trillions of closed holes. Okay. All right, let's look at your domain. Your domain is tricky. Your domain is your x's. Okay, let's think about this. What's the leftist part of the graph? This left arrow? Yeah, okay. Okay, just tell me, what does this arrow mean? It means infinity. Right? Arrows mean infinity for sure. But what are the x's as we go left to get to that infinity? They are negative, -2, -3, -4, -5, Okay, so anyway, this infinity is actually going to go all the way to negative infinity. Because arrows mean infinities, and because they keep on going, and this is going to keep fluctuating, just going back up, back down, back up, back down. So it's always going to be in between the y values of -1 and 1. But the x values, they could go on forever to the left, or they could keep going on and forever to the right, where x is +itive infinity. Okay, let's write our domain now. The smallest x value, is it this -1 on the solid curve? Nope. What about here? -2? Nope. What about here? -3? Nope. Because this is going to keep going on and 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 on. Anyway, so negative infinity. Remember, infinities, you hug it with a parentheses, okay? The biggest x value is a +itive infinity, and you hug it with a parentheses. Okay. Y-intercept. Let's see here. Y-intercept is where we touch the y-axis. So the y-axis is up and down. Hey. And where does this curve touch the y-axis? Well, we already figured that out. It was 1. Or, let's write it as an ordered pair. And if you're freaking out because of the parentheses and the brackets, Domain and range is the only time you ever use brackets. Spelled that wrong. Only time we use brackets. Okay, but you get the point. So domain and range, I think I'm dyslexic, are only, those are the only things that will have brackets. Everything else, like an ordered pair, will have parentheses. Okay, so the y is 1 because I went up 1. Yeah, okay. And then the x, well, I didn't go nowhere. And technically, right up here in the middle is an x value of 0. All right. So my y-intercept is 1 or 0, comma 1. Yeah. Okay, let's keep going. It says, for what x is f of x equal to 1? So this is the bass-ackward thing. Okay, so first it says, for what x? So that means x equals question mark. Because who, what, when, where, why means question mark. So what x means x equals question mark. Okay, and then this hoopla that they gave us is supposed to always look like f of x equals y. So that means your y is a 1. Alright? Okay, so let's go and see. I'm looking for an x value when y is 1. Well, here's an x value of 0. Okay, there's another y value of 1 right here. What? What's this ordered pair? Because it has a y value of 1 also. Let's see how many we had to go over. 1, 2, 3, 4. Okay, 4. Okay, so that's another x value that has a y value of 1. Oh no, there's another one up here. Oh no, there's another, but that one's off the graph, so I'm not going to write it. Okay, over here on the left, I think this is 1, 2, 3, 4. So that's another x value that has a y value of 1. And technically, this is going to keep going. You won't have one of these on your homework with the dot, 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 but I just wanted to show you that it could happen. Okay, let's look at this f parentheses negative 4. Remember, that means f of x equals that. Okay. So we're looking when x is 4, negative 4, what's my y value? Okay, so in this little box, I have to put my y value. So first let's find when x is negative 4. X is the left and right, so let's go left 4. 1, 2, 3. Oh, hey, little doggy. Okay. But then you got to go up or down, because now we're looking for the y. And you got to go up or down until you get to that curve. Well, let's just pretend it was a good picture. And I went up 1. Then the y value would be 1. Okay, let's keep going. Let's look at this f parentheses 0. Again, that means f of 0, f of x equals y. Okay, so we need to find when our x value is 0. X goes side to side, 0 is in the middle. Then we need to write down our y value. And remember, the y value is the up and down part. So when my x is 0, here it is. How much do I have to go up or down to get to my curve? I had to go up 1. Oh, look, we already wrote that point. When x is 0, y is 1. Okay, yeah. Okay, let's keep going. Then it says f parentheses 2. Okay, so that means when x is 2, we have to figure out the y. So let's go find 2 on the x-axis. X is side to side. 2 goes to the right. 1, 2. Hey, here's 2. Okay? And then now we need to write down the y value, which is how far we go up or down to get to our curve. So where do we have to go? We have to drop it like it's hot. Over here, down to negative 1. Until we're on top of the point that looks like 1, 2, 2, comma, 2 to the right, down 1, negative 1. So the x is 2 and the y value is negative 1. Woo! Okay, and this one was kind of rough because all the 1s and knowing when to use a bracket and a parentheses. Yeah. Okay, so hopefully that was a better video for those of you who were having a little awkwardness with these graphs. And then again, the blank copies of this and the worked out copies of this worksheet will be on your Blackboard. Okay, have a good weekend. Don't forget you don't have any homework. This was just for if you wanted more practice. Okay, bye. Have a great night.